So far, we've only written programs that are sequential. That means that the commands are performed in the sequence in which they appear in the program, and all commands get executed every time the programs run. This is not typically practical. In general, any but the simplest programs will make decisions and selectively perform computations based on those decisions. The types of decisions that programs make are generally based on the output of relational and logical operators, which are the topic of this video. As I mentioned, most computer programs will need to make decisions and selectively execute commands based on those decisions. The process of selectively performing commands based on the result of decisions is called flow control. Flow of the calculations through the program is controlled by the decisions being made by the program. The other terminology relative to this process is that commands are executed conditionally. Some condition or set of conditions must be met before a given command is executed. The types of decisions made by most computer programs are the result of simple true or false calculations, or questions where answers are either yes or no. So the general decision being made is that if this is true, then do one thing, but if it isn't true, then do something else. Special operators, called relational and logical operators, are used to decide whether something is either true or false. To understand how Octave's relational and logical operators work, it's first necessary to understand how the computer represents the concepts of true and false. Computers represent the concepts of true and false as numbers. These numbers are interpreted as either true or false, so they're called logical values. As usual, only the user, you, know for sure whether a number should be interpreted as a logical value or as a more garden variety number, and you need to use it appropriately. Specifically, when you use a number in Octave as a logical value, Octave considers any number which is not 0 to represent the logical concept of true. When you ask an Octave operator or function to return a logical value, Octave will always return a 1 to represent true. Alternately, in the context of a logical value, 0 is interpreted as corresponding to false. Octave's mathematical operators require the user to make sure that the operands that are sent to them meet the rules for the type of arithmetic that was being done. Likewise, Octave's logical and relational operators require the user to keep track of how those operators interpret the operands that are sent to them. Now I'll go through the list of Octave's relational operators. Remember that for these operators, the operands are interpreted as numbers and the output is either a 1 or a 0 for true or false, respectively. In Octave, the operation greater than is represented by the typical mathematical greater than symbol, and less than is represented by the mathematical less than symbol. Greater than or equal to and less than or equal to are implemented in Octave with the greater or less than symbols followed by an equal sign. The logical operator used to check whether two numbers are equal to one another is simply two equal signs. The logical operation that checks whether two numbers are not equal to one another is a tilde followed by an equal sign. All of these operators have the same precedence, and any of them will be done after all mathematical operations are done. So the command 5 plus 3 equals 8 adds 5 and 3 to get 8. Then it checks to see if 8 is equal to 8. That's true, so Octave returns a 1 as a result of this operation. Since all the relational operators are of the same precedence, relational operators are performed from left to right, just as mathematical operations of the same precedence are performed. So the command 2 less than 5 less than 3 checks whether 5 is greater than 2 first. That's true, so Octave returns a 1. Then Octave checks to see whether 1 is less than 3. Notice that inputs to the relational operators are used as numbers rather than logical values. 1 is less than 3, so Octave returns a 1. And this overall expression is true. This is different from the conclusion that would be drawn from a typical mathematical notation in which 2 less than x less than 3 would check whether x is between 2 and 3. This mathematical notation would be false if x were 5. Now I'll do a couple of demonstrations of relational operators using Octave before talking about logical operators. I'll do a couple of very quick demonstrations of the relational operators just so you can get an idea of what the results of the operators look like. First, if I type 1 tilde equals 2, I get a response of 1, since 1 is not equal to 2 and the relation is true. If I type 1 equals 2, the result is 0. 1 is not equal to 2 and the result is false. Next, I want to take a quick and informal look at some issues associated with equalities and inequalities. One predefined variable is called EPS. Computers represent values to only a finite precision. EPS is the minimum value by which two numbers have to differ before Octave can tell that they are actually different. So I can check to see whether 1 is equal to 1 plus EPS. So 1 equals 1 plus EPS. This is false since Octave can tell the difference between numbers that are separated by EPS. However, if I type 1 equals 1 plus EPS over 2, I get a 1 back. Octave considers the number 1 plus EPS over 2 to be exactly the same as 1. This is called numerical round-off error, and it can be a problem with numerical analysis. I'll talk more about numerical precision and round-offs in a later chapter. Finally, I'll try to determine whether a particular value lies within a certain interval using only the Octave relational operators. I'll set x equals 3, and then type 0 less than x less than 4. This returns 1, which seems reasonable since 3 is between 0 and 4, but that's not why the result is true. What's actually happening is that Octave is checking whether 0 is less than 1, which is true, so a 1 is returned for that part of the expression. Then Octave checks to see whether 1 is less than 4. Since that is true, Octave returns a 1. But now I'll redo the problem with x equals 6. If I type x equals 6, 0 less than x less than 4, I get 1 from this, or true, which may not be what I expected. 6 is not between 0 and 4. In this case, Octave first checks whether x is greater than 0. 6 is greater than 0, so this operator returns a 1. Since this logical 1 is less than 4, the result is true. So to check whether a particular value lies within an interval, we need to use a logical operator in conjunction with the relational operators. I'll talk about logical operators next. Finally, I'll talk about the logical operators that are available in Octave. For logical operators, both the operands and their result are logical values. You can still use any number as an operand to the logical operators, but Octave interprets these numbers as logical values. Operands that are not 0 are interpreted as being true, while operands that are 0 are interpreted as false. As with the relational operators, logical operators return either a 1 or a 0. 1 is returned if the result is true, and 0 is returned if the result is false. There are 3 logical operators that I'll use in this course. The first of the logical operators is AND, which is implemented in Octave with an ampersand symbol. The result of an AND operation is true only if both operands are true. If either or both of the operands are false, then the result of the operation is false, and Octave returns a 0. For example, pi and 2 is true, since both of the operands are not 0, and Octave returns a 1. pi and 0, however, is false, since one of the operands is false and Octave returns a 0. The next operator is a logical OR. In Octave, it's represented by this vertical bar or pipe symbol. On most keyboards, this is the uppercase version of the \. key. The result of an OR operation is true if either one or both of the operands is true. So if at least one condition is met, the result of an OR is true. For example, 0 OR pi is true, since pi is interpreted as being true by the operand, and this returns a 1. 0 OR 0 is false, since neither operand is true. The final operator I want to mention is the NOT operator. It's represented by a tilde symbol. NOT simply inverts the logic of a single operand. So if you apply a NOT to an operand that's true, you get back a 0, or false. And if you apply a NOT to a false operand, it returns 1, or true. So NOT 0 returns 1, and NOT pi returns a 0. The precedence of all of the logical operators is the same, and all of the logical operators have a lower precedence than the relational operators. So the overall precedence of the operators I've talked about so far is: first, mathematical operations are performed relative to their rules of precedence. Relational operators are evaluated next. And finally, after all else is done, the logical operators are evaluated. Parentheses, as usual, can be used to override this default precedence. In this demo, I want to revisit the problem I did at the end of the last demo. In that demo, I wanted to decide whether a value x is between 0 and 4. When I do this, what I'm really checking is that x is both greater than 0 and less than 4. So I can use a logical AND in conjunction with two relational operators to check this condition. So first, I'll check my value of x, which is still 6. Next, I'll type 0 less than x, ampersand x less than 4. In this statement, I'm taking advantage of the precedence of operations. Both relational operators will be evaluated before the logical operator. So the statement first checks whether x is greater than 0. That's true, so a 1 is returned. Next, the statement checks whether x is less than 4. That's false, so a 0 is returned. The AND operation between true and false is false, since both operands have to be true for the result to be true. So this statement should return a 0, meaning that 6 is not between 0 and 4. I'll check this by pressing enter. Now I'll redo the calculation with x equals 3. Now both conditions, x greater than 0 and x less than 4, are true. So the result of the AND operation should be true or 1. I'll use the up arrow to repeat the statement. It looks like the command does just what I expect it to do. That's really all there is to logical and relational operators. You do need to know how these operators work to use them successfully. However, you generally will not need to deal directly with the output of logical and relational operators, since they're usually used in conjunction with programming structures that deal with the result of these operations. In the next couple of videos, I'll talk about using logical array indices and introduce one decision-making structure commonly called an if block.